Good afternoon guys, I'm Chris and welcome back to this Wednesday's episode of Rift Amps. Right, just making up some more Ainsley Lister signature boards, and so I have drilled these and I've installed the eyelets in, and what I do is I just hold them down with some electrical tape because now I've got to swage them in, and there is a special tool which I have shown on the channel before, but I'll show you again. It's just this long rod here, and it's got a special sort of tapered pointy end on it, which swages the eyelets into place. And what I found is normally you just push down and that swages them, but I found you get a much better fit and finish if at the same time you spin the tool. That's why I do it in my drill press. You get a much nicer seating of the eyelet. And so that's what I do. It's quite simple. So that's 3 done just there. Hopefully you can see. And I'm just going to go through and do both of those boards and get those done. But that's one of my tips for you. If you're ever doing eyelets, don't just push them in, spin them in a bit as well, and you get a really nice seat. Apologies about the continuity problems in this video. I filmed some stuff tail end of the last week, some stuff this week. I've had a haircut in the meantime, so deal with it, all right? Anyway, thanks to all the lovely comments on the DSL50 video. What I love about Mauser, and that's who I've ordered it from, is they ship from America, Grand Prairie in Texas. And if it wasn't for the weekend, it would have been next day delivery, because it's just turned up. The transformer has just turned up. Today is Monday. I ordered it on Friday. Absolutely incredible. In fact, it had landed in the UK on Saturday. So, as I said, if it wasn't for the weekend, it would have been here next day, which is amazing. So I'm going to get that installed into the amp, all fired up, get it all tested, and that will be done. I will show you that, of course. But yeah, what amazing news, and thank you so much to all the comments on the video. Very tricky diagnosis, even though the result is what you might on paper say is pretty obvious. The problem that I was having, and the reason I left a lot of that footage in the video, because I wanted to show you what it is like sometimes, especially when you get intermittent problems, but they're also repeatable, as in your measurements are repeatable. So I'd go in and I'd measure the resistance of one half of that winding, and it'd be correct. I'd measure it again, it would be correct. I'd measure it a third time and it would be correct. So that's repeatable. You then go off, measure something else, come back and re-measure that winding for a fourth time, and then it'd change. And then you'd measure it again, and the change would be repeatable. So the new reading would be the same. You go off, you test something else, you check something else, you come back, and it's then reverted back. And that's the difficult thing, is when you're getting an intermittent fault, but it's not quite intermittent enough to give you the solid data that you need to make that diagnosis. And so you have to go through that process, and it takes time. And as I said on the video, yes, it would have been easy just to call the output transformer, fire the parts cannon, and you probably would have been right. But, and this is what I say, what if it turned out to be something else, and you just spent 100 and whatever pounds, £136 delivered it was, probably about $160, I would have thought, and it turns out it wasn't that. Who's paying for that? You can't make mistakes like that. You've got to be 100% in your diagnosis. So that's why in the bonus footage, I did then 100% confirm with the unit outside of the chassis that it was faulty. So yeah, really, really interesting. Lots of comments and questions on it. One of them that I wanted to read, and I've just got to find it, so bear with me, it was from Midnight Hour, who is not actually talking about the DSL, but I think it's an important point. He says, "Hi Chris, just wondered at the busiest time of year how you decide to manage your time between builds and repairs. Do you ever have to say no to repairs, or is it just a case of telling customers the estimated long lead time and leaving them to decide? Do you ever get annoying 'are we there yet' customers?" All the time. So the way I do things, the way I split my time is, and I say this on the channel quite regularly, primarily I am an amp builder, an amp manufacturer, and that's the core of my business. It is the priority of the business, and it's what I focus most of my time on. And I spend most of my day doing amp builds, and that could be chassis wiring, it could be populating hardware, it could be drilling cabinets, it could be anything related to the manufacture, supply and shipping of brand new guitar amplifiers. That's what Rift is and what Rift does. The repair side of the business is extra to that. It's a top up of that, but it does now bring in a substantial portion of the business's income. And if you're going to do right by both the amplifier and the customer, you have to dedicate a proper amount of time to that amplifier and to that repair process. So you can't just keep dipping in and out. You know, you have to be able to spend dedicated time doing your job properly, right? And so the way I generally do it is I build for most of the day, and then for a couple of hours each day, I will be focused on the repair and servicing side of the business. I work simply on a first come, first served basis, and there's a queue system. So the quicker you get your amplifier into me, the quicker I'll get onto it. I don't do reservations, I don't do bookings. You can tell me when you're going to drop your amplifier in or send it in to me, although I'm not currently accepting full amplifiers by shipment at the moment. But from the second they arrive here at the shop, they are in a queue and I get to it when I get to it. And that's the way I work. And if you are on a deadline, the only thing I can say to you is that you need to get your amplifier to me as quickly as possible. But what I certainly won't do is prioritise your amp over somebody else's, because if they've been in the queue longer, they get priority. That's the way it works. If I'm working on an amplifier and I'm waiting on parts, or the diagnosis is pretty tricky, and I do have time to jump onto a very simple repair like a speaker swap, or fit some output valves and bias them, I will do that, because you can't ever just sit around idle doing nothing. But it's simply a case of, it goes in the queue and you wait your turn. And if you need something quicker and I can't do it, then you are more than welcome, and I'm never offended by this if you take it somewhere else. So that's the way I decide to do things. But because I'm not a dedicated repair shop, as in that's the primary focus of the business, I am a manufacturer and builder, the repair side is always secondary to that. And if you want me to look at your stuff, you go in the queue and you wait your turn. People do chase me for stuff, asking me, is it done yet? Can I get progress and updates on that? And I always say to people, look, if you want me to do the best job I can, you need to wait and you need to be patient. And if you keep chasing me, the more time I spend on the phone and the more time I spend answering emails is less time I'm spending doing quality work, high quality work on amplifiers, and you wouldn't want me to skip that on yours, would you? So that's the way I work. But yeah, it's a great question, Midnight Hour, and it seems to work for me. It seems to work great. It's just at this time of year, as it always is, post festival season, you just get a lot of inquiries and a lot of work coming in. So, but the same rules apply. It goes in the repair queue. Right, both boards done. So now I can remove my tape. And this is the tricky bit, because sometimes you'll get a piece of tape inside the eyelet and then you have to fish it out manually. So if you pull these off carefully and at just the right angle, you don't get any stragglers. Jason Klutz says, talking about the Kingsley pedal here, he said, "Hi Chris, I would be curious to see if the bypass signal going through the new switch in the Kingsley pedal still drops voltage. Maybe it was the context of the bad switch, but if it's still dropping voltage, I'm wondering if the load box was loading down the function generator signal." So two things there. The voltage it was dropping was almost insignificant. You know, we're talking, it was 20 millivolts drop, right? So hardly anything. And that's simply just the natural internal resistance of any component or any switch that your signal has to go through. What you've got to remember is that this signal strength coming out of the signal generator is very weak. There's not a lot of grunt behind it, so it's going to suffer some drop anyway. And it's always, I mean, you can measure it. You can measure what's coming out of a signal generator into the input of an amplifier. By the time it gets to the input grid of the first stage, it's already dropped a few millivolts anyway. So it's a non-issue there. Your point about the load box is simply just to put a tiny load on the output of the pedal. It's simply a 1 meg resistor in a box. The reason I built it is that it gives me two nice connection points for the scope. And the reason I use a 1 meg is because that's the standard input impedance of a guitar amplifier. So the pedal is seeing the correct load that it would see in its normal application. So no, it's nothing more than basic physics. Rainmaker, channel member, says, "Great to see a Kingsley on the bench. Absolutely killer pedals." Do you know, I was genuinely surprised by them. I don't know much about them. I tend not to live in the world of pedals, so I know I'm not a proper pedal nerd or geek. So, but it was nice to see inside. I like the way it was built. I like the way it was designed, and it sounded great. So, yeah, great. He said, "I was sceptical until I first tried a Page, but became a believer quickly after. A question for Chris for next week. My amps tend to sound somehow sweeter after about 20 minutes of being played. Is it simply placebo? The valve's finally getting up to full temp, or are there other elements in the amp that sound different after getting warmed up?" Yeah, the speaker. You'll hear it more with Alnico speakers, than you will ceramics. But yeah, it does happen. It's genuinely an issue. The voice coil gets warm, the magnet gets warm, and you do get a change. Whether that change is pleasing to the ear or not is entirely up to you. That's a subjective thing. But yes, there is a noticeable and measurable change that happens. So no, it's not you, mate. It genuinely is happening. And it's fascinating. It genuinely is fascinating. So, yeah, what a great question. Right, DSL50 output transformer. The Hammond 1750P, I believe. Let's get this thing unboxed, installed in the amp, tested, get the bias done, and get this amp done, dusted, out the door. And there she is, 1750P. Right, where's the old one gone? So we know it's the same size anyway, in every dimension, but it does want me to reuse... No, it doesn't. It doesn't want me to reuse the hardware. Ah, even better. So I haven't got to do any swapping. So I marked this up in a certain orientation so I know which way round it needs to go. So the old transformer went that way. So this transformer, as everything lines up the same, is going to go in this way. Do you know what I should do? Do you know what I should do? Let's just check that they're all tight, so we don't end up with any... See, that one was loose. Any buzzing laminations. So we're going to go that way, that way, that way, and in she goes. 1, 2, 3, 4 pieces of hardware, and a washer as well. This is where we find these nuts aren't the right size. No, they're too small, too big. They are too big. The original nuts are too big. Hold on. Maston Bro says, "Hi Chris, the fact that Ainsley is coming in and signing off the latest build signatures is so cool. Is it normal for an artist to sign off on a signature piece, or is this something that you and Ainsley came up with? Curious to know the background on this. Cheers from the Netherlands." Well, I can't speak for other people, but it's something we do. We decided to do it together. We firmly believe that if you're going to put your name on something, you should be testing it and playing it and signing off and make sure it's good. It's not always possible with the bigger brands because the volume of units they're doing is too big. But, you know, Ainsley and I have been doing this for a long time. The rate that the units go out mean it's easy for Ainsley to pop in, play them. And he's great because I trust his ears. I trust his ears, I trust his fingers. I trust him to be able to point out things that I might not immediately pick up on because of the way he plays guitar compared to me. And he's very, very good. And this is what we discovered during the design and development phase of that amplifier, is that he can zone in on something and demonstrate it to you in a way that makes it really obvious. And then, so he's really, really good at converting what he's hearing, a minute issue that he's hearing, or minute change that he's hearing, and, for want of a better word, amplifying it to a point where someone who's not playing the amplifier can hear it and understand what's going on too. Now, these amplifiers, and I'm building one here on the bench, the SIG, is very highly stressed and it's very intolerant of component tolerances, in that we've discovered there are certain components within the circuit that, I'm not going to give away secrets here, but for example, let's take a 100k resistor. If the resistor measures 100k, the amp doesn't sound right. We know that that resistor needs to be on the lower side of its tolerance, and it is a measurable, perceivable difference. Same with certain capacitors in the circuit. We know that they have to be either higher or lower, or bang on their particular value to make the amplifier do exactly what it's wanted, exactly where it needs to be. I mean, ideally, every capacitor and every resistor would be variable, and then you could dial them all in perfectly to where the amp wants them to be. Not possible, but we've learned over time how to get the amps, just, you know, that final 0.5% to get them to really sing. And it's really difficult. And often I need Ainsley playing the amplifier with his Strat through his touring speaker so we can both hear those final nuanced changes. And I love it. So yeah, it's something we decided to do together. And once he signed off on them, he literally signs the certificate, and then I do too, to say this amplifier is good to go and it's passed all of our testing. So yeah, it's really, really cool. I love it, and it's great because we can always compare them to his touring amp. We can not only measure or you know, and get them really close, but we can also compare a brand new amp versus how his amp ages over time. You know, he's got, you know, hundreds and hundreds and hundreds of gigs on that amp now, and we can say, well, actually now after X amount of playing hours, that amp has changed in a way that we hadn't predicted. That's fascinating. Let's understand that, and let's see if we can either build that into new builds because we like the change, or we don't like the change, and let's find a way to stop that happening. And so having an serial number 1 coming in every time as our datum, as our reference point, is brilliant, and it's great, and we love it. So yeah, what a great question. Thanks for asking. Annoyingly, the Hammond uses imperial hardware. I thought, being Canadian, it'd be metric, but it's not. It is imperial. It needs a number 8, which thankfully I've got a set of. So we'll get these in, we'll get it all connected up on the test bench, fired up, and then that's it really. Biased up, and providing it's all good, we'll burn it in for an hour or so, and if it passes all of that, we'll call it good. Oh, I forgot to say, the I did swap the screen stoppers on that 2-rock. Remember, one of them was slightly discoloured. Well, it measured 560 odd ohms and it should be 470. Whereas the other one actually measured 460. So quite a big difference between the two. And it was biased screaming hot. So it's had those resistors done, all biased up, all tested. And he's actually been to collect it and taken it away. All good. So yeah, nothing much really more to report on those 2-rocks. The other one just didn't play up at all. Absolutely no issue with it, no problem. So he's going to, if it does play up again, I've told him to try and make it repeatable. So at least he can then demonstrate to me exactly what it's doing in person. Because whatever I did to it, however much I abused it, however hot I got it, however many pedals I slammed the front end of it with, it just did not want to play up. Right, where's that data sheet gone? Now, because I did this job a couple of days ago, I've forgotten. You always forget stuff. So on my phone, and you know this is one of my top tips, I did take a photo of how the wires went. And what I'm going to do now is just cross-reference those with the data sheet for the transformer, just to make sure we've got everything the way it should be. So pin 2 should be our centre tap, which it is, which is the same order as before. Pin 4 should be purple, which it is. And the other one was pin 7, which is white, correct. See how easy that is. Right, now the secondary side, we had red at the very top, which would be pin 14, which is 16 ohm, correct. Then we had orange, which should be pin 16, which is 8 ohm. That's correct. Then we should have green, which is 4 ohms, and that goes to pin 21, which is again correct. And finally, black is your common, which goes to pin 23, which again is correct. See, it's that easy. It really is that easy. So what I'm going to do now is grab my multimeter and let's take some measurements. So we should now have roughly 41 ohms each side from our centre tap, which is there. So to the white side, which was always the good side, we've got in circuit 38 ohms, and on the blue side, sorry, the purple side, the one that was faulty, we've got 39 ohms. You see that? Yeah, perfect. Exactly what we needed. Right, so spin this thing over. CompuBias. Let's get these in. Grab our output valves. Right, I'm going to set this up on the test bench. We're going to soft start it because we've done a major repair to the amplifier. Connect the CompuBias up, and then we can get this thing biased up and test its output. Randomly selected user back on the Kingsley here says, is it just me or was the waveform for that pedal slightly distorted in the post-switch swap scope shot? As in, the centre of the tops of the bottom seems to be shifted to the left compared to the first test. Also, the bottom seems to be to distort more. It was simply the EQ settings on the pedal. I didn't test the pedal with the same knob settings pre and post. It was more just about confirming the operation of the switch. So yeah, good spot. But the answer is as easy as you think it is. Just wasn't the same test conditions. Okay, you are back with me on the bench. I've got picture-in-picture going, so you should be able to see a shot-down view of the chassis. The Hammond is now installed. The amplifier has been switched on, has been soft-started, all was okay. It's now in full power mode, so the amp is getting maximum voltage. And before we do anything, let's just set our bias, shall we? So, rough rule of thumb is as long as our bias ends up somewhere between 50 and 70% of the maximum plate dissipation in a push-pull Class A amplifier fixed bias, we're generally happy, somewhere between 50 and 70. So let's go halfway to that point, 60 as our starting point. And so we simply go 25 watts is the maximum of an EL34 times by 0.6, means we're looking for about 15 watts at idle. The CompuBias is showing we've got 14.1, 4.6 it's flickering, but 15.5 on the other. So we will, using the adjustment on the back of the chassis, we will just tweak that until we get these two. If I set them both at 15, I will be happy. So I'm going to go ahead and do that now. Unfortunately, there's not a flattering angle of this unless I do this. Well, that looks good, doesn't it? Here we are. Right, so, actually, I'll tell you what. How does that look? That looks all right, doesn't it? So there's two mini trim pots on the back here, and I've got the CompuBias right here. And we're just going to adjust each side until I get my 15 watts each side. That was easy. That was really easy. Look on the big screen, there you go. Almost perfect anode cathode voltage, 469, 470 each side, exactly 32 milliamps flowing through each valve, gives us 15 watts of plate dissipation. Now, yes, for the pedants out there, I know that does include the screen current, but if we include that, we always end up slightly on the safer side than we would do if we didn't. So let's come back here. Bring you back up. Hopefully you can still all see me and you can all hear me. We're still running in here. So we're biased up, no smoke, no fire. That's good news. So if we now connect up to the oscilloscope, we'll set our signal generator to our standard 0.15 volts RMS, so 150 millivolts RMS. I can inject that into the front end. I can move this to show you the scope, and we will start with the green channel. I've got the volume on max, I've got mid control on max, presence control on maximum, everything else on 0. We advance our signal. And we'll bring it up to the point of clipping there, and we'll just back it down. And that is our output sine wave. And if you look at the bottom left-hand corner here, we're getting 19.6 volts, 19.2, 19.6. There you go, that's 20 volts. Now, we're into 8 ohms. So 20 squared, 400, divided by 8, 50 watts. We're getting 50 watts out of the amplifier. How good is that? I'm going to leave that running as it is. If we zoom in, we can see we do have a tiny, tiny bit of crossover distortion there. So these valves probably want to be biased ever so slightly hotter. So should we go up to 65%? Let's do that. So 25 times 0.65 puts us at 16.25 watts. They've actually crept up slightly. I haven't touched the bias yet, and we're currently at 15.5 and 16. So they're not exactly happy, are they? Tell you what. Let's just go the other way, shall we? 20 watts output, 20 volts output, which was there on the volume control. Back to idle, and let's just bump these up to 16.5. Yeah, I can get it to 16.4 on the CompuBias. And that's our output sine wave. Ignore the thing, it's because I'm going to the scope reference to ground. I think that's lovely. I think that's a really nice output sine wave for a DSL50. It's as good as you're going to get with one of these, let's be honest. Right, so I'll leave that running as it is for, we'll definitely give it an hour, maybe a smidge more than that, maybe a little bit more than that. We'll see how it goes. It's currently pulling at rated output 160 watts out of the wall. And that sounds about right to me. Does it tell you the maximum? It says 175 watts at rated output, so we're actually pulling slightly less. Well, that's good news. That's good news. Output transformer replacement on a Marshall DSL50. We'll leave it burning in. If anything changes, I'll come back and I will let you know and report back. But if it doesn't, we'll call this one done. This is quite an unusual amplifier. A Marshall JCM 50/25. It's the 2550 model. Now, I know what most of you are thinking. Hold on a minute, isn't that a silver Jubilee? And yes, you would be right. The 2550 model was the silver Jubilee. Introduced in 1987, you know, in the silver Tolex with the silver cloth. You know what they look like. You know what they are. Really, really cool things. The further down the line, as far as my Bible says anyway, they did some of them in the black Tolex, but it did say they retained the silver control panel. Now this one has got a gold panel, is signed Jim Marshall on the plate itself, so that's part of the silk screening or the engraving. And I've had a look online and I've seen another couple of examples in the black Tolex with the gold control plate. The information that is online isn't particularly, I don't want to say trustworthy, but it's not. There's a lot of conflicting information about it. I think that's a fair way of putting it. So I don't really know how rare these are, other than I've not seen one before. But the circuit inside should just be standard silver Jubilee, which is really quite cool. So single input, you've got input gain, lead master gain, output master volume, treble, middle bass and presence control. High and a low output switch here, on, off and standby. And we spin this thing around. The serial number is Y08426. Model number 2550, output power 50 watts, input power 175 watts, exactly the same as the DSL, do you remember? Manufactured by Marshall in Bletchley. All your standard stuff on the back. Voltage selector here, output impedance selector here, which I do need to swap to 8 ohms because that's how I test everything. Where's my good screwdriver? I'll find that in a minute. 2 outputs here. Got a DI, you've got a send and return, and your foot switch as well. Now, the customer did bring his foot switch with the amplifier. Single channel switch here, and I don't know if this is original for the amp or whether this is a reissue. It looks like your standard off-the-shelf Marshall foot switch, but I'm sure some of you are shouting at me right now, telling me I'm wrong, and that's a super rare foot switch. I'm not really that clued up on these. So what's it in for? It's coming for a service, and the customer says it has a hum, which he would like rectifying. Hopefully it's something simple and easy and not expensive for the customer, because we don't want to be going down that route if we don't have to. So the easiest thing for me to do, as always, is we pull this back panel off. Now, what I have noticed, it's very rattly. That's not going to be fun, especially if this is sitting on top of a 4x12. So we will look at that to see if there's anything we can do to improve it. Might just be that one that's loose. Yeah, I think that hole stripped slightly and it wasn't grabbing. So what do we see? What do we see inside this amplifier? So it's got the original LCR filter caps, 1, 2, 3 of them, probably all 50-50, so they're two 50 microfarad caps in each canister. We've got very tight valve sockets, Marshall branded EL34s made by Tungsol. There you go. We'll plug that back in. I can see it's got a Drake choke here, dated February 1990. Sorry, output transformer. The choke here, January 1990, and the power transformer, February 1990. So it's probably a 1990, which would make sense. If the Jubilees came out in 87 and the later ones were done in black Tolex, then maybe that is correct. Okay. Let's pull the chassis from the amplifier. Customer says the thing works, but it's probably a good idea, just for me, as always, give it a visual inspection inside, make sure there's nothing burnt, any liquid damage, anything blown, you know the score. And then we'll stick it up on the test bench and we'll take some basic measurements. Okay, I was expecting there to be a lot more going on inside this chassis than there actually is. This is fascinating. So, first things that we see are the board is dated, or the design of the board dated 1998. There is a sticker on the outside of the chassis that tells me this particular unit was assembled 5th of March 1990 by a bloke called Mick. There you go. Nice and clean inside. Hardly any dust. I mean, you can see how shiny it is. This is very nice indeed. So, visual inspection, of course. We'll start with the main board. I'm hoping this all comes across on camera. The larger the resistor, as a general rule, the more power it's having to handle. So these large resistors here, these 10Ks, all look to be in reasonable condition. There's no signs of burning or overheating. So nothing downstream of these resistors is putting too much current. These two electrolytics here will be in the bias supply, and I can confirm that this one here appears to be slightly leaking. There is also an electrolytic at this end of the board. This one here, which, actually on camera it doesn't look too bad, but to the naked eye it does look a bit crusty on this end. Interesting. So we can certainly test that. What else have we got? Looks like there's been something on this board. Not sure. We've got a radial capacitor here, this 470 microfarad cap. Because you can't see the positive end, it's difficult to tell, but I'm convinced the top side, that vent cap is starting to bulge, so maybe that's going to need replacing. we come across that 22 microfarad. Visual looks okay. Okay, and there's nothing else on this board, at least, that I've seen. And if you spot something, let me know in the comments. Nothing that I can see that looks out of place. Right, if we come round, we spin. Oh, whoops. Won't be doing that again. Let's look down at these two filter caps then, these two can caps, and once we get the shaking to stop, you can see this one starting to bulge. Definite bulge there. And there's one there as well. So I always think, right, well, what's in terms of replacing components, would you rather replace those capacitors, or would you rather not replace them and risk at some point blowing one of the transformers? Well, I know what my answer is. So my recommendation will be to swap these out. If we come around and look at, I've done it again, this can cap here, you can see as well that's got a bulge there too. So it's fair to say that all three of the LCR filter cans are reaching the end of their service life. Let's have a look at these output valve sockets. Start with this one here. We've got a 2K2 10 watt resistor here, which has got signs of something going on with it. It's definitely had some heat going on. And the one next door, over here, arguably the same again. Now, 2K2 screen stoppers, probably a good thing. Probably a good thing. Look, going back to the sockets though, let's have a look. They don't look too bad. 5K6 grid stoppers, control grid stoppers. The sockets themselves, not too bad. I've seen far worse before, so I'm not really concerned about those. We come over here, we can look at our preamp sockets. That's your phase inverter. There's something going on with that yellow wire. Would you say that's got some insulation damage? Something weird there. Come across to this socket. Can't see much, nothing to complain about. And finally, this one over here. And we've got a snubber cap between cathode and the anode. What value is it? Can I get a reading on that? 470 picofarad. That little ceramic disc there. Okay, so inside has revealed some things. We've definitely got our main filter cans that need doing, in my opinion. The smaller ones on the main board, definitely the two in the bias supply I would do. You know my rules. B plus rails and bias supplies and main supplies all need to be strong. And then if the board's coming out, we may as well do these three. Is it 3, 1, 2, 3? Yep, at the same time. And that's about it, really. We haven't spotted anything obvious. or anything that really gives us cause for concern. So let's fire this thing. I'm happy to fire this thing up on the bench anyway. We can take some readings. We'll get FFT plot out, get a baseline noise floor measurement, and go from there. Right, fired up on the test bench. No issues whatsoever, no problems firing this thing up. I've got the compu bias in, and you can see we're currently biased around 29, 30 milliamps per side, giving us around 13 watts of plate dissipation. So we'll go with the highest 113.3 divided by 25, means we're biased at 53% currently, which, as it is, and you know my rule, anywhere between 50 and 70% is a happy place to be. That's good news, right? So, and as these things settle down, you see it does vary slightly with wall voltage. We'll let it keep coming up to temperature, get some heat into those valves, get some heat into the sockets, into the components, and just kind of see where we actually end up. But we're not biased too hot, is the headline that we're trying to point out. Sorry, having a bit of a brain fart then. Okay, so before we do anything else, then we will take a power measurement on the oscilloscope. So we will get my signal generator as usual. Sorry, there's no picture-in-picture at the moment. So we'll come over to the scope. Okay, so we're looking at this VRMS figure here for 50 watts into 8 ohms. I've set the impedance to 8 ohms. We're looking for 20 volts, just as we had on the DSL. And we will master on full. Either I've got this channel switching the wrong way round. Yes, I think I do. There we go. Right. So up to the point of clipping, back it down. Can I get to 20 volts? Just about. That's 20 there. Little bit of clipping, but it's not struggling to do 50 watts, is it? You know, we're not stuck down at 10. Whilst I've got it running like this, let's just flick the power switch on the front that gives us 50 watts down to 25 watts. Let's see what that does. Here we go. Okay, so output's definitely dropped. If I bring it down to the point of clipping again, we are getting 12.5. Should we be generous and call that 13? 12.5, 13? What do you think? We just started to square off there. So if we called it 13, 13 squared divided by 8 is 21 watts. So we don't quite get the 25 watts, but we do get a nice volume, well, so output drop there. Go back to big power. And there we go. So my EQ settings for this, as always, middle on full, presence on full, everything else on 0. Okay, so the amplifier is performing and it's putting out the sound. The output sine wave is not horrible. Something interesting going on just at this point here. Can we amplify that? You can see there's a little lump there and a little lump coming down, but just on the upper peak. It doesn't appear on the lower. So something to take note of. Let's come back out. Right, so that is that. The amplifier is certainly doing something, and I can certainly smell that the output valves are working. That's good news. Right, signal generator out. We're now about 14 watts at the moment, so we've come up by 1 milliamp. So we're definitely working those output valves. That's a good sign. Quite like this. Not disappointed whatsoever. Right, let's get FFT plot. And then we can take some measurements at the output. So we'll switch to my bench cab. All the controls now on 0. Up against the speaker. I've just got to sync the two, bear with me. Well, I don't know about you, but that's one of the quietest amplifiers I've ever had on my bench. That's phenomenal. I mean, look at this reading at 100 hertz. Let's get to 100 hertz. Well over negative 70 dB at 94 hertz there. That's incredible. I don't know what the guy's talking about. No hum whatsoever. I mean, if you look at noise at, let's say, 5K. That's negative 100 dB. Right, okay. Let's mess around with some controls, see if anything changes, shall we? So if we go master up full. That's all the controls on 10. That's incredible. That is incredible. I don't think I've ever seen a Marshall that quiet. That's unbelievable. There's no hum in that amplifier. There's no hum whatsoever. Okay. So I need to give the customer a call and ask him some questions then, because that's... For a Marshall of this era, they normally are quite noisy, but this thing is... I barely tell it's on. That's amazing. That is amazing. So maybe he means there's a hum when his guitar's plugged in, but that will be injected noise. We can double check that we haven't got a dirty socket or something like that, but I've never had readings that low of an amplifier dimed. That's wonderful. Wonderfully quiet. Okay, I'm going to go call the customer and I'll come back. Right, just got off the phone with the owner and I've told him what I found, what I haven't found, what my recommendations are. He wants me to go ahead and do the recap and any service work that's preventative whilst I'm here, which I think is a good, sensible option, especially for an amplifier like this and the one that he's going to be using regularly. He said he was using it at a gig and he did get quite a strong mains hum, but it could be a venue problem. It could be that he was using lots of different effects. Maybe it was a dodgy cable or whatever. But fundamentally this amplifier is strong. It's strong and quiet and sounds ridiculously good. So yeah, I'm going to go ahead and order up some nice replacement filter caps and bits and pieces for the front board. He wants me to, as I said, go ahead and do lots of preventative maintenance work on it so he can use it live and not have any, you know, question marks in his head about reliability or anything like that, which is good, which is a good thing. And I'm certainly happy to go ahead and do that for him. So yeah, that's what we're going to do. I think that's really, really interesting, exciting, fascinating. I can't believe how little there is and how much space you've got inside this chassis. It's on at the moment, so I'm not going to stick my hands in. But yeah, there you go. Marshall 2550. Well, that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up. All of your comments and questions down below. Subscribe if you haven't already. Hit the notification bell so you know when new videos come out. If you're feeling super generous like these guys have, maybe consider joining the channel, and I will catch you all at the next one.